Hello everyone, and welcome back to our channel. Today, we're diving into a fascinating topic in computer science, the microkernel. You might have heard this term tossed around in discussions about operating systems, but what exactly is a microkernel, and why is it such an important concept? Let's find out. Before we delve into the depths of the microkernel, let's start with the basics. A microkernel is a minimalist approach to designing an operating system. Unlike traditional monolithic kernels, which handle everything from managing memory to handling system calls within a single kernel space, a microkernel takes a different approach. In a microkernel architecture, the kernel is stripped down to its essential components, with most services traditionally provided by the kernel, such as device drivers and file system management, moved to user space as separate processes or servers. This design aims to improve system stability, security, and modularity. So, why go through the trouble of breaking down the kernel into smaller pieces? Well, there are several benefits to the microkernel architecture. Modularity. One of the primary advantages of a microkernel is its modular nature. By separating essential kernel functions into independent processes, developers can update or replace individual components without affecting the entire system. This modularity promotes flexibility and simplifies system maintenance. Reliability and security. Another key benefit is improved reliability and security. With fewer functions running in privileged kernel mode, the attack surface is significantly reduced. Any potential vulnerabilities are confined to isolated user space processes, making it harder for malicious actors to exploit the system. Customizability and extensibility. Microkernel architectures also offer greater customizability and extensibility. Developers can tailor the operating system to specific use cases by choosing and configuring only the necessary components. Additionally, new features or services can be easily added without requiring modifications to the core kernel. Now that we understand the benefits of microkernel architectures, let's explore where they are commonly used. Embedded systems. Microkernels are popular choices for embedded systems, such as automotive infotainment systems, IoT devices, and aerospace applications, where reliability, security, and resource efficiency are paramount. Real-time systems. Due to their predictable behavior and low overhead, microkernels are also well-suited for real-time operating systems used in industrial control systems, telecommunications, and mission-critical environments. Research and experimentation. Finally, microkernels serve as a fertile ground for research and experimentation in operating system design. Researchers often use microkernel architectures as a basis for exploring new ideas in system scalability, fault tolerance, and distributed computing. In conclusion, the microkernel represents a fundamental shift in operating system design, offering increased flexibility, reliability, and security compared to traditional monolithic kernels. While it may not be the silver bullet for every use case, understanding the principles behind microkernel architectures is essential for anyone interested in the future of computing. That's all for today's video. If you found this exploration of microkernels informative, don't forget to give us a thumbs up and subscribe to our channel for more tech-related content.